What's up guys, it's me Sir Ernest, and today we're going to answer some problems involving Ampere's law. The problem reads, a thick slab extending from z equals negative a to z equals positive a and infinite in x and y directions carries a uniform volume current J given by this. Find the magnetic field as a function of z for both inside and outside the slab. Okay, because one of the clues that we're given is that it is infinitely extending in both x and y directions. Okay, so that means we do not have to worry about the edges of this slab. Now, if we're going to redraw this as follows. So let's say this is your z and this is your y. So your slab would look something like this. Okay, so this is your slab. So from here we can look at 2 Amperean loops. So let's start with the first Amperean loop. Because of this, we can choose this Amperean loop of length L and then n height Z. Okay, and we can choose the direction of the loop as follows. So by right hand rule, the magnetic field points in the negative y direction for z greater than 0, and b points in the positive y direction and for z less than 0. So this is for by right hand rule. Now at z equals 0, okay, so magnetic field here is in this direction. The magnetic field here is pointing in this direction. But at z equal to 0, the magnetic field is 0. Now for the first loop, okay, we're considering the region where z is less than a and z is greater than negative a. The Ampere's law, b dot dl close integral, which is basically equal to bl, because our L here would be this L, and then this is equal to mu naught I enclose. So in this case, I enclose would be the current here, current by this area. So that is current times area. The area of this loop is L times Z. So this is I enclosed would be LZ times J. So therefore, and the direction is along the Y direction. So B is now equal to negative mu naught J Z Y hat. Now for loop number 2, we can do similar thing, but we need to check 2 regions. One is above because the magnetic field is different above and below the y-axis. So let's start with when z is greater than positive A. So that means this is our Amperean loop. Okay, in this case, I enclosed would be equal to what? I enclosed would be equal to this area only. So this is L times A. Remember, this is A. So this is LA times J. So above, the direction would be negative. So B is equal to negative mu naught J A. Then Y hat. And lastly, for Z less than negative A, so this is our Amperean loop, I enclosed would be equal to negative, enclosed would be equal to LAJ. So this is also LA. Okay, so therefore the magnetic field would be equal to positive mu naught JA Y hat. Okay, so this is now the magnetic field as a function of Z for both inside and outside the slab using Ampere's law. Okay, so again, if you have questions during these discussions, please do not hesitate to contact me. You know how to contact me. But for now, that's all, and that's all for this problem. I hope you learned something today, and I'll see you guys in the next video. Bye bye.